Welcome to the Road to Autonomy, the podcast shaping how Wall Street and industry executives think about the autonomy economy. For today's executives and investors, simply following the headlines is not enough. That's why our clients go beyond the podcast and the headlines to get exclusive market intelligence and industry briefings. See what they see. Visit roadtoautonomy.com. That's roadtoautonomy.com. David, the automotive industry is changing. Magna's sitting at the epicenter of this. It's becoming automated and it's becoming software defined. You're an engineer. How are you thinking about this rapidly changing automotive market?
Hi, Grayson. Thanks for having me. It's great to be here. You nailed it. I mean, rapidly changing is definitely the name of the game here. When you look at, the hardware is changing, more and more sensors, different kinds of sensors, volume of sensors on each vehicle, cost of sensors going down. Then you've got the compute platforms, the curves as you go, very rapidly through time. The compute is growing almost exponentially. The cost is also coming down. The expectation from customers is going up. You look across markets, especially look into the Asian markets, and you have some pretty amazing things happening at very low price points as far as urban navigation on autopilot and those types of features coming out. So, rapidly changing, and we're doing our best to stay ahead of the game there.
How do you stay ahead of the game? Because if you look at the Chinese market in particular, they have well received, well regarded vehicles at low price points that are intuitive, software defined. Is that the early hints of a trend that might work its way to the east?
Yeah, I mean, I think one of the big shifts towards a centralized architecture is really helpful there. So, I mean, once you can kind of simplify the vehicle system to have a kind of single large compute, then you can think about a lot of things like sensor fusion, and you can think about replacing sensors over, vehicle iterations. It's not a whole rewrite of the whole system. Getting that in place kind of in the now time frame so that in the next few years you can kind of start to move those feature sophistication forward. That's what we're trying to do.
From a systems perspective, I'm going to correlate this to, let's say, a Boeing and Airbus, a large jet airline, where they have the fly-by-wire system, then they have the IFE, the in-flight entertainment system. The wires never cross. Is it fair to think about that from a vehicle standpoint, where you have the autonomous driving system, the ADAS system, and then you have the, let's call it the in-vehicle infotainment, where those wires never cross, or the bits and the bytes, they never touch?
Yeah, I think different customers have different viewpoints on that. I think we're kind of exploring both ways. Some really want to merge things, and some really want to keep them separate. So, do we do them on different boards? Do we do them on the same board on different chips that are isolated, or do we treat the whole system together? I mean, I think all those are still options. That there's not a single way forward. That's kind of agreed on in the whole market.
Why do you think that is? Is it just the engineering cultures of your customers, or is it just we're still such in the early days, we're still trying to figure it out?
Yeah, I think a lot of it may be kind of legacy mindsets that are just tough to move. I mean, there's a lot of momentum in some of this stuff. I've been kind of automotive adjacent for a lot of my career, and have only become in automotive for the last few years. So I mean, some of that mindset is a little bit clashes with some very modern, general engineering principles and software engineering principles, and just ways to think about, networking across various components and things like that. That some customers have adopted very quickly, and others have a lot more momentum. So, Magna tries to supply, all of those players, and we don't necessarily intend to drive them in a direction, but rather kind of support them in what they're trying to do.
You mentioned the adjacent. I would say you had one foot in automotive technically because you were at a world-renowned mapping company, and now you're at a world-renowned automotive supplier that, in my opinion, does a lot more than just does that. You're building the future at Magna, which raises the question about maps. There's a big debate in traditional automotive. There's a big debate in Silicon Valley. Mapped, mapless. How are you thinking about that? Because you have years and years experience developing maps.
It's been a fun ride. So the HD maps, maybe mid 2010s started to be kind of a real phenomenon. The thought at the time was you need an HD mapping company. They're going to maintain the world's maps, and then you're going to build ADAS features on top of those maps. I still fairly well subscribe to that. I mean, I have a lot of bias because of that background, I guess. But as the features become more sophisticated, you kind of start to see the value in that. If you look at a simple L2 system with your adaptive cruise control and your lane centering, those you don't need maps for, right? Those are just very responsive to the environment. You're looking kind of directly ahead of you. You're looking kind of directly down at the lines ahead of you, and that's all you need to control those features. These days, if you start to look at highway assist types of features and highway navigate on autopilot, where now you need to understand the relationship of some junctions from the on and off ramps. You need to understand what you have to work with as far as adjacent lanes and shoulders and things like this. The map starts to be very valuable. Then you start to look in urban cases, and now you've got intersections and multiple traffic lights controlling multiple lanes and multiple turns through the intersection. So having some of that information as a prior is very valuable. I think there are for sure companies that would argue, hey, if you can see it and you're a human, then you can drive it the same way with a camera and a chip. Probably true, and maybe in 10, 20 years that can be more true. But I think now having that at least as a prior, if not as a kind of a redundant system for cases where you can't see everything, is super, super valuable.
So do you view maps, let's say, just we'll simplify this, an L2 system on a highway. I'm going to use simple things because I'm Florida. So Miami to Orlando, just on that stretch of 95. So let's say that's mapless. And then when you get into more complex, you want to go from downtown Brickell to Disney World, because you have to go off the highway, believe it or not, to go to Disney World. You can't drive right in. Does that become map? Is that kind of how we should think about it? Because you're adding a little bit of complexity on each end?
You're talking about, do you drive highway mapless and then switch to a different system when you get off the highway?
Yes.
I think it's a little bit dangerous to have to switch systems hard like that, because then you have to develop two systems. I guess it's possible. The trick with maps is freshness, right? So that was the whole exercise at a mapping company. So we spent a few years prototyping, building HD maps from data kind of automatically, and that was kind of successful. And I won't say easy, but kind of like straightforward. But then you start to look at the logistics of how do you keep these fresh over time, and immediately get into concepts of crowdsourcing, because it's just simply too slow and too expensive to drive industrial capture vehicles at the rate that you need to make sense. And then you have kind of all kinds of conflicting reports from different vehicles, and you got kind of the frequency of vehicles that you can expect on different kinds of roads. I mean, it becomes a kind of a nightmare of logistics to keep that fresh. And so then the question is, how, if you don't know how fresh it is, or if you can't keep it fresh, then how much can you trust it? Or, can you trust it at all? And the amount that you trust it, can you even get any value out of that? I think still the answer is probably yes, if you treat it in the right way. And I frankly, I don't think that we can do enough in real time without any priors yet that I would say we should not have maps. But I think that's something that some companies are looking at, and we keep an eye on for if there becomes a way to do it without a map. I think that would be a great system complexity reduction. But for now, I think the maps are useful.
From a cost perspective, utilization perspective, you can also throw safety in there as well. Do you see primarily maps being used in controlled ODDs where robotaxis are, because those vehicles are constantly going and updating the maps and they're running in a constrained environment instead of that Miami to Orlando, which is, it's a common route, but you're not going to have the freshness that you are of running in a constrained ODD with robotaxis?
Well, if you're just using the map to check, are you in the ODD? That's kind of a simpler use case. You still have to be very careful there, that GPS precision and localization are working in harmony and all those kind of things. So, constraining the ODD is one thing, but actually using the map during the drive policy. So as you're doing trajectory planning and things like this, that's, I think, where it becomes more valuable.
And so, since we're on the controversial topics, I'm going to throw another one out at you. LiDAR, because you have LiDAR experience. What are your thoughts on LiDAR?
Yeah, it's been amazing to watch it evolve over the years. In grad school a long time ago now, we were using Leica scanners where you have to take them out of literally a trunk and put them on a giant tripod, and they take half an hour, and you can literally watch the laser strips, going up and down the scene. So from that to where we are today, it has been unbelievable to watch, and the cost reduction has been equally as wild. My take on LiDAR is, we still use LiDAR for ground truthing, even though we don't develop ADAS systems with LiDAR. So there's some implicit, we believe in LiDAR enough that we take that as the right answer when we try to, find what's happening in the scene with radar and cameras and other things. We say, well, what did the LiDAR see as we're developing that? And that becomes kind of the gold standard. Of course, multimodal sensors are critical as you start operating in more complex environments. When you have inclement weather, when you have nighttime, when you have all of these types of situations, lidar may not always be the best. In a nominal conditions, I think it's kind of still the gold standard though. So as the cost continues to come down, we'll watch if customers are willing to pay for it, and we can show them the value that you get in your ADAS stack out of having it there. That'd be great. As you start to need more redundancies, so you start looking at level 3 types of situations. That's one way to get an extra redundancy. And then as you start to get into, Magna's not specifically looking right now at level 4 types of robotaxis, but those companies all seem to be using lidar. So there's obviously something to that, or they wouldn't be doing that. So it's definitely a hot topic.
It's a hot topic. Another hot topic is the 4D radar. John Deere through Blue River recently acquired Spartan Radar, and they had really great software algorithm running on top of 4D radars. Are you currently looking into 4D radars and what you can do with them, especially from a software perspective?
Yeah, so we have an imaging radar product that's kind of amazing. I mean, you can get such a higher point density when you're looking to, if you use a traditional radar, you're looking mainly at kind of obstacle identification and obstacle avoidance types of things. It's very hard to classify without additional sensors like cameras and other things. And as you look into prediction, I mean, you get just kind of a rough blob. It's much harder to tell which way is it oriented and those types of things. So with something like an imaging radar, you can do that much more effectively. I mean, it's not certainly not a lidar, but it's kind of going in the direction of lidar, and you get a lot of the same properties that you get with traditional radar, as far as robustness to different weather conditions and those kinds of things.
So you mentioned that Magna, from an ADAS perspective, is not using lidar on your ADAS suites, and then when you go into higher levels of automation, you said that you are using lidar. How do you find, from a development standpoint, as you're developing and testing these products, the sweet spot from a sensor perspective?
Yeah, the ODD is everything, right? So if you are going to be operating at high speeds, you need to be able to see far into the distance so you have time to react. If you're operating in urban environments, you need lots of different, sensor placement on the vehicle to try to avoid occlusion as much as you can. If you're operating only in daytime, then you can think very differently. If you're operating only in non-snow, non-rain conditions, you can think very differently. So the problem statement is really essential. I mean, it's very hard to say, okay, let's assume nothing and then pick a sensor suite, right? It just doesn't make any sense. You really do have to design the vehicle system to the intended use case. It's simply too expensive to make it work in all conditions at the moment.
Do you just also take into account the design of the vehicle when you're looking at that potential ideal sensor suite? How it looks, how it functions, where you could put a sensor? Because from a consumer standpoint, I'll call it, the consumer doesn't want to buy the Lego car. Okay, we gotta plop this down. Plop. No, they want a smooth. I'll use my father-in-law's line. I want smooth lines, kid. I want smooth lines. Consumers look for that when they purchase vehicles.
For sure, for sure. And something like a radar you can put behind the bumper and is literally invisible. People are getting pretty used to seeing little camera lenses poking out from places, and I don't think that's a big deal these days. The giant spinning lidar on the top of the roof rack, that's a very different look for sure. Again, the regional markets have very different opinions on that. So my understanding from my last trip to China was that customers there get excited and say, "Hey, it's got lidar, so it's a fancy car," right? So that's very different than what you're saying, where people here say, "What's the big bump? I want the big bump gone," in the U.S. Europe markets. So it's not, the aesthetics are not a worldwide. They're not standard necessarily worldwide, but for sure those are considerations. I mean, I don't get into the aesthetic design of the vehicle. But of course, sometimes the customers will come with a constraint like that, and then you have to work around it.
It's interesting because there are certain manufacturers where the badge means a lot from a perspective. That's interesting about the Chinese market. I never thought about that. I was in London last week, and I saw this white van going around, and I was like, "Oh my god, it's got a lidar!" I tried to look closely. It was just something to hold it on there, but it was one of those things that caught my attention. It's really interesting that you bring that up. So let's stay on the consumer vehicles here, because you're developing this software, you're prototyping it, you're deploying it. If you want to call it, the brains is the compute, is the power that enables the sensors, enables your software to run. How do you think about compute? Do you say, "Oh, I got to have as much compute as possible. I got to be open AI, and I got to have a gazillion data centers." You say, "Wait a second, I want the R model. I want as little as possible because I want this to run."
Yeah, I mean, we're right on an inflection point of how these vehicles work. So I mean, there's kind of now what I'll call like traditional ADAS systems, and then there's what we can see and starting to roll out a little bit of what I'll call very modern ADAS as a systems approach, and that's how much AI or machine learning that you're using in the system. So if you very roughly divide an ADAS system in half, you've kind of got the perception half. So that's take the input from the sensors and build yourself an environment model, which means now I know where the road is, where the lines are, where the obstacles are, where the signs are, everything like that. So that's your environment model. The environment model then is kind of the input to the second half of the system, which we call drive policy, or the behavior of the vehicle. So what do I want to do, and how do I execute that within the environment that I've just built for myself with the perception stack? So for a while now, AI ML has been used in the perception half of the system. This is very standard. This has now been with the convolutional neural network revolution 10 years ago. We're getting pretty good in the industry of detecting objects in cameras, and now doing some sensor fusion with cameras and radars and those kinds of things. What hasn't yet really taken over is AI ML in the second half of the system. So we kind of have what we call rule-based operation in the drive policy system now, where we say, okay, given this environment model, here's the objective I want, and I'm going to use kind of an algorithmic approach where we say we'll use this type of planning algorithm, and then use this type of obstacle avoidance, and turn a lot of knobs and say how aggressive you want to be and these kind of things. Where kind of where it looks like things are heading in the future, and the question is how fast can we get there. But let's now take a machine learning approach to the second half of the system, where we say, here's your input, here's how a human driver behaved, or here's how some kind of existing system behaved, and let's learn how to produce that behavior with an artificial intelligence. You can now get into all kinds of modern things, and you can use LLMs for some of this. But what my point to answer your question is, when you make that jump, now all of a sudden you have a compute problem on your hands. With these traditional approaches, we're starting to have enough compute in the car where that's not necessarily the limiting factor right now.
Interesting. You're right. So right now, the drive policy is it's set. Again, it gets shipped into the vehicle, and then in the future, I'll use the word potentially, it could go to more algorithmic. Is that a fair way to summarize that?
Yeah, I mean, it's the kind of holy grail is what they're calling end-to-end systems. So that's kind of sensor data in and vehicle actuation out. There's kind of well-known problems in academics of what I guess they call like inspectability. So it's kind of understanding what the network is doing. So not always do you want to treat it as just a giant network like that. That division in the middle still is very useful for human understanding. So you can actually see the environment model before you kind of continue with the system. So just to try to help understand, where the deficiencies are. But in spirit, what the goal is to have none of the algorithms that have been written by humans, but let the AI figure it all out. You got all kinds of big bombs that come in with how do we guarantee safety, and how do we think about testing those systems, and so there's a revolution on the horizon. And frankly, that's what my teams are looking at. So in the division of Magna Electronics where I live, we're called technology strategy. So we're trying to identify those trends, get ahead of those trends so it doesn't happen and we watch it fly right by us, because there's major things both on the kind of the vehicle architecture and compute side. There's kind of the pre-vehicle stuff in the sense of what do we need for as far as machine learning infrastructure and machine learning operations at the company. So there's a lot of stuff that we want to be prepared for when it finally comes. We can kind of stay ahead of it.
Because EDE is bubbling up. I mean, the research is vast, and you're starting to see companies look to commercialize EDE. But with all due respect, they don't have your balance sheet, and they don't have your reputation, so they could do things that you're not able to do. Do you see a point? And I don't know if this is possible, where you get an EDE, but you kind of put guardrails or verification around it? Is that even possible?
Although we're not building level 4 systems ourselves, I mean, I follow that space quite a bit because there's a lot of good lessons to be learned there. That's definitely what a lot of companies that are successful there have been doing, where they're essentially they take a machine learning approach, they output several kind of strategies, and then they have a couple of kind of traditional strategies, and they try to look at what's the difference between those. If they're very drastically different from each other, they kind of throw flags. So I mean that's those guardrails and checks using traditional methods are definitely still in a lot of cases the approach to the kind of safety problem in a sense. The trick is, as the situation get more and more complex, then the traditional methods are going to stop working at some point, and then what do we do then? I think the thought is that we'll kind of develop strategies and solve a lot of those problems for how do you treat the testing and validation by the time we need that to be the only backstop, right? So the traditional backstop will, I mean, it has to eventually go away. All of this is a matter of when.
When do you think is when?
I think there's kind of the running joke, right? Everybody about every 5 years somebody comes and loudly says it'll be ready in 5 years. It's definitely been about the last 20 years, and I think it's still happening literally as we speak. So can I be first to go on the record and say 5 years? No, it's I bet it'll be a good decade. There's a lot of runway left. I think we've got you get the SAE levels of automation, right? We're still operating in level 2, but in fact I gave a talk recently. We called it scope creep in level 2. So what used to be level 2 and still is definable as level 2 is adaptive cruise control plus lane centering, right? That's obviously not what we mean by kind of advanced level 2 systems anymore. So we've got official terms in the industry of level 2 plus, level 2 plus plus. Then we start to talk about level 2.9, and this kind of some of them are jokes, but some of them are kind of seriously trying to indicate how this system is really advanced past what the kind of baseline definition of level 2 is. But we're still not prepared to be confident enough that we can call it level 3. So it's a matter of how much redundancy you have before you can get into a level 3 system.
Because I feel the level 3, at least from a policy standpoint, opens a can of worms, because then you get into the liability issues, which, for the record, in my humble opinion, have not been solved yet. But you're right about plus and plus plus. It started in the media, Disney Plus, this service plus, everything got a plus. And then in automotive, he said, no, we have to have 2 pluses. And then I'm going to go on the record and say this, we're probably going to have 3 pluses at some point. It's just the way that things are moving, and the technology is moving so quickly. Do you look, when you're developing the internals, because it's simple, the level 2 ADAS systems inside Magna, do you look to potential partnerships with ADAS startup developers, or do you build it all in-house, or how are you looking at these, well, you said E2E, but these new emerging models, these new emerging technologies and ways to solve ADAS?
Yeah, I mean, we're always on the lookout for which option is best. We don't have a philosophical we're going to do this all in-house because we want to, and we don't have a philosophy of we're going to go make an acquisition or a partnership to do it, right? We're kind of literally day to day, month to month saying what's the best strategy. So all options are kind of continuously on the table. So once in a while, we see something come around that looks promising, and we try to do some proof of concepts together. We have to always consider the kind of long-term maintenance and stuff like that too. So there's a lot of considerations. It's really a complicated problem, but that's what we do, is try to make recommendations around those types of things.
I mean, that's a great way to be, because you're having the ability to see things, and you have the resources, if so choose, to make a decision. And if you staying on that trend, you look at major trends that are emerging today. One of the biggest trends now is the licensing of ADAS systems, and I say that does include L2. We have a very public partnership between Helm AI and Honda. You have one between Wave and Nissan, I believe, based on the press release. That's for the Japanese market. We have no indications it expands outside of that. But Honda, they're ramping up in 27 with the Helm vehicles. Do you see this trend continuing, where you have these global manufacturers are looking to license stacks?
Sure. I mean, that's definitely a valid approach, right? I mean, this is a hard problem to solve. Magna's kind of a traditionally automotive manufacturing company, and now we're kind of getting into this very high tech space very rapidly of ADAS systems, or ADAS software systems, right? So there are very different business considerations. There's a lot of upfront investment, and sometimes when you look at what these partnerships that you see that you just named, all these other smaller companies have been able to make those investments because they come from very different types of investors. and they've got different timelines and all these kinds of things. So sometimes once it kind of matures, then and it's ready for prime time, there's no reason to then compete against it. You might as well use it. So that's we're like I mentioned, still trying to make those decisions, right? We have to pick a direction, in the next half a decade, so that we're kind of set up for success for the longer term future. And those decisions have to happen now.
No, but you are making decisions. Magna, in my opinion, has the right leadership to make those decisions. And if you look at the course of Magna's history over time, Magna has continued to make, in my opinion, the right ones. And that's why I'll say it for the record, you're the leading tier one supplier, because the decisions that the executives have made over the years. I'm curious now, from a software perspective, how long has Magna been developing ADAS software internally?
Yeah, well, I've got almost, I think now 4 years with Magna, so it was well underway by the time I got here. So, but I can't speak necessarily to the longer history than that.
And do you see that Magna's commitment to software, developing software for ADAS, but eventually going to potentially to higher levels, accelerating over time as the demands of your customers increases?
Yeah, absolutely. I mean, the customers come with very high expectations these days. Even over my tenure here, the sophistication in-house has gotten, substantially better. So we're definitely on the right trajectory. We got to just keep up the trajectory because everybody else is keeping up the trajectory. I mean, it's really, again, another recent talk I gave, and we called it the race to autonomy. We talked about a little bit. What we're realizing though is, right, it's okay. There's obviously some element of a race in the business sense still, but it's not a single person, single company who's going to take all the elements and push them all as fast as they can to the goal, right? It's really a partnership or an ecosystem that has to develop. And as a tier one, we're well positioned to kind of foster those types of relationships and kind of build those ecosystems. From our compute partners, you've seen public news with some big collaborations with NVIDIA recently. That's going to be a huge one. The software stuff that we've been talking about with these end-to-end systems and some of these AI approaches, you're starting to get AI in the cabin, right? So kind of simplifying the user interfaces for a lot of things and more natural discussions with the vehicle in natural language. We can't do all of that ourselves at a kind of level that the customers and the consumers expect. But we still have to provide systems that offer all of that, right? So we have to pick and choose where does it make sense for us to kind of become the experts, and where does it make sense for us to keep our kind of capacity as an integrator and do that integration in a way that makes a lot of sense.
You hit the nail on the head. It's an ecosystem. You just can't to say, "Oh, I'm going to make a car drive." It's called biddity boppity boop, and away it goes. There's a whole there's software, there's infrastructure, there's hardware, there's connectivity. You and I can go on for days about all the pieces of the ecosystem that need to make this to work. And I'm thinking a lot about the ecosystem because there's a lot of, I'll use the word controversy in the market, where some firms, not going to name names, think that they can build automotive grade hardware. And then you can meet all the ASIL standards for software. And then there's other firms say, no, we need to have a partner. Do you ever see a point in the future where you have a corporate contractual relationship with a startup where you become their automotive grade partner to meet all the automotive safety standards and also become their integrator? Because do you see anything like that potentially happening in the future?
Yeah, I mean, I don't have any specific examples to name, but Magna is very good at that stuff. Frankly, that stuff is a whole different type of hard, right? So I come from a software background, mostly algorithm level. When you start looking at safety systems, you talked about ASIL and those kinds of things, and you've got the different MISRA standards even for the software itself. That's a whole nother expertise that actually Magna does very well. Could we do that as kind of a software supplier in some sense? Yeah, I think it's possible. I mean, everything is possible. It's just a matter of where we want to focus our kind of limited energy and attention, and what makes the most sense for the business.
That's a great answer. I like that answer. I was at a conference last year, and this individual gave a presentation about all the lines of code in a car and how it's rapidly grown.
Yeah.
Your software engineer, does that trend continue? Do we just continue to see more and more lines of code in that car, or where do you see that going? And then does it get to the point where there's too much code in the car? Is it's too bulky? When do we hit that, if you want to call that that tipping point?
Well, I think, I mean, it's gonna reverse direction for sure with this introduction of AI, right? So anytime you introduce a neural network or similar that's able to do a lot of these functions, you get to remove a lot of code, right? So you're trading off lines of code for a little bit of uncertainty in the behavior, right? But that's where I think the testing becomes really important. And that's another area that we're looking at really intensively is kind of how can we use simulation and synthetic data and all these types of things to, as a way to develop answers to how can we prove this is safe if we can't audit every single line of code. That's a huge open question in the industry, and that's something that I think we're again pretty well positioned. We've got really big validation teams and stuff like this, so we've kind of got the kind of knowledge and the manpower to adopt some of these new techniques, and it's a matter of kind of choosing the right ones at the right time.
Is that where digital twins come into the picture?
Yeah, digital twin. I mean, that's a little bit of an overloaded term. So depending on who you talk to, you'll probably get 10 different definitions. You can talk about digitally twinning the hardware, where you talk about VECUs and kind of modeling the sensors and all that kind of stuff at the physics level. You can talk about, kind of what I'll call ADAS level simulation, where you're taking video game engine types of things and running around creating scenarios to see how the ADAS stack would behave. So there's a whole deep stack you can talk about when you talk about digital twins. Some element of that is already happening, and all of those elements are really impactful and essential to success in the future. As these systems get more complicated, it's not a matter of, okay, we'll take it in the parking lot and drive it around and call it safe. You've got so many edge cases to handle now when you're moving into these urban navigate on autopilot cases, features specifically. Did a dog jump out in the road? These are now things that are actually possible and that you have to handle properly. When you're restricted to the highway, again, for my mapping language, we call these limited access roads, where you kind of are allowed to make the assumption that nothing's going to enter the roadway except from the ramps. You can absolutely not make that assumption when you're in an urban environment. So it's really the road is really a wild place. I mean, it's so much more complex than you would ever just casually think about when you actually study what's happening there. And being able to handle those situations is really complicated.
I went for a ride around urban London in an AV last week. And some of the stuff I saw, I've never seen here in America. First of all, on the left-hand side of the road, so that was cool. But some of the, if you want to call it pedestrian behavior, it's like, well, I've never seen that before. You have to plan for that. And then I saw something I never saw, and the vehicle handled it flawlessly. Was a double roundabout. It's like, what the heck? And people come in there, my daughter calls it Mario Kart driving. They come in there, Mario Kart driving, and then consumers jump off the curb. You have to prepare for all this stuff.
Yep. And that's where having a good testing strategy is really essential. They used to talk about the number of miles. So they say, okay, if you have 1 million miles of data and you can pass it all, then you're safe, right? I mean, yeah, to how many nines and to what level of confidence? I mean, so that's kind of we're going to continually chase those nines. And you've got now, I talked about an ecosystem. It's not even just an engineering ecosystem. Now it's a regulatory ecosystem. It's a consumer trust and consumer thinking ecosystem where, how safe is safe enough for the regulators? How safe is safe enough for the consumers? You see amazing progress, and then there's one incident after, hundreds of millions of miles, and then the whole company, not our company, but you've seen in the public eye, a whole company loses trust and loses funding because of one incident. So to hold the industry to that high of a standard, I think is I'm not going to comment on politics here, but I think it's not necessarily in the best interest of progress, right? We have to always be cognizant of safety, number one, for sure, but we can't have such a high bar that we don't make any progress. And so finding that balance is really essential.
We have to move forward. If you study history and you go back to the railroads or the introduction of the automobile, there were incidents, and there was a public trust was built. There was a really great book. It was called The Vagabonds that was written. It was about Thomas Edison, Henry Ford, Firestone, and I forget the other gentleman, and they went around on these famous road trips to introduce the vehicle to the public, and it started to build this trust. Oh, Mr. Ford is coming, Mr. Edison is coming, and they'd have parades. We also saw that with the airplane with Charles Lindbergh, and when he did the tour of St. Louis, where they would go out and build public trust. It's an industry that we have to build this trust, because at the end of the day, autonomy is going to unlock the ability for individuals to have better qualities of life. I think that you hear these stories over and over again around, I had to have the talk. You're like, oh, here we go again. Dad, mom, no more driving, got to take the keys away. Well, if you introduce higher levels of autonomy and you eventually get to full L4, you don't have to have the talk anymore. And then think about it from your parents' perspective or your grandparents' perspective, how much better of a quality of life they can have.
Yeah.
They're fully independent. Oh, I want to go to the beauty parlor. I want to go play croquet. I want to do this. They can go do it.
Yeah.
It changes everything.
Yeah, I mean that has been the vision for literally decades, and I think it's still the vision. So I mean and we'll get there, right? I mean I can pretty confidently tell you that we'll get there. It's again a matter of when. In the meantime, right, when we're not talking about level 4 and we're talking about level 2, you've got still I think it's improving over time. We look at the kind of consumer surveys every year, and I think it's for the most part getting better over time. But you've got still pretty big factions of people that say the first thing I do is figure out how to turn off all the annoying beeping. Guys, those beeps are supposed to be helping you, right? So, but there's certainly room for improvement there, right? So some of that we can take lessons and find better ways to interact with the driver, right? We're starting to Magna's got some driver monitoring systems that we can do a lot of nice things with. We got different kinds of in cabin monitoring for driver and other passengers. So I mean, there's with the introduction of now some of this LLM stuff in the cabin, it's definitely going to improve in the near term. The question is some of the mindsets, are they so dug in that they're not going to change no matter how good this is, or is it really actually the beeps are kind of annoying and we need to do better, right? So it's probably somewhere in the middle there.
I think it's somewhere in the middle, and I think that if you look at an older individual, say north of 70, that their children could say, oh, Dad, Mom, you do this, this, and this, and then okay, and I think it's just getting over. Once you get past the annoying beep, 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 oh, okay, this is cool. And so when you put your driver monitoring or you put it's a feature into their screen, okay, this is much better. That's that blasted thing, or how they can get with no filter, that kind of goes away. And we do know that autonomy is going to scale. L2 is going to scale. L4 is going to scale. In your opinion, how do you see autonomy scaling across the globe? And do you see perhaps certain pockets and certain markets being primarily L2 markets, where other markets will be L4? What are your thoughts on this scaling?
Yeah, I mean, it seems like there's very different markets right now. At least I don't know what the future will bring, but nobody's trying to deploy L4 cars to the consumer on highways and everywhere, right? So they have these very very constrained ODDs that are per city basically right now for any of the L4 deployments, and it's a very small number of cities. So I don't think we wait 2 years and then they just break down those lines around the cities and it just magically works. That's kind of like the L5 dream, right? That almost basically nobody even talks about anymore, which may also come, but I think we're talking about multiple decades in that case. So yeah, right now that hasn't really been a there's not competition between L4 and L2. It's kind of pick a lane and operate in your lane. At some point there will be a convergence discussion, but I mean I think that's very far in the future. Right now the hardware is different, the algorithms are different, the approaches to the system are different, the regulation and testing is different. So it's really different. I mean, Magna has had a kind of public, hey, we're not operating in L4. We're going to continue to watch that space very closely, right? At some point it's going to be the right time, but right now L2 is where we're operating.
And L2's a growth market. L2 is going to continue to scale. And if anybody has doubts, go look at the public filings of all the publicly traded automotive companies and just go in the EGRET database and just simply type in Command F level 2, and you will see that all these major auto companies are investing in it. L4 is going to scale, and autonomy is going to scale globally. And as autonomy scales, Magna will be there and continue to be there at the center of this. The future is bright. The future is autonomous. The future is Magna. David, thank you so much for coming on the road to autonomy today.
Grayson, I appreciate it. It's been fun.